if you could watch a planet being born, not in a simulation, not in theory, but in real time, growing, shaping its star system, and carving its place in the cosmos? For decades, astronomers have searched for proof of how planets like Earth and Jupiter first emerged out of swirling clouds of dust and gas. We thought we knew the story, but until now, the evidence was circumstantial. So, what if I told you that for the very first time, astronomers have directly caught a planet in the act of forming inside a gap it carved for itself in its star's disk? What does this discovery mean for our understanding of worlds beyond our own? And could it reveal secrets about how our solar system was born? Stay tuned, because by the end of this video, you'll see how we're finally witnessing one of the universe's greatest secrets: planetary birth unfolding before our eyes. Welcome to Astroracle, where we explore the vast universe together. Every star is born surrounded by a protoplanetary disk, a massive rotating halo of gas and dust left over from the violent collapse of a molecular cloud. Think of it as cosmic debris from the star's birth. Inside these disks lies the raw material for planets. Dust grains collide and stick together, forming clumps. Over time, clumps become boulders, boulders become planetesimals, and eventually, gravity takes over, snowballing these fragments into full-fledged planets. But this process isn't smooth. As young planets grow, they plow through the disk like bulldozers, clearing out gaps and leaving behind dramatic rings. For years, astronomers pointed to these gaps as indirect evidence of newborn planets, but proving it was tricky. Was it really a planet doing the carving? Or could other disk processes, like magnetic instabilities or turbulence, create the same patterns? Until now, the case was circumstantial. But thanks to cutting-edge telescopes equipped with extreme adaptive optics, systems that cancel out Earth's atmospheric blurring, astronomers have captured direct, undeniable proof. A planet inside a disk gap, actively feeding on gas and dust as it grows. The planet in question, nicknamed Wispit 2b, lies within a beautifully structured, multi-ringed protoplanetary disk. Using the Magellan telescope in Chile and the Very Large Telescope, scientists were able to spot it not just in infrared light, where hot young planets glow, but also in a specific, unmistakable signal: H-alpha emission. Why does that matter? H-alpha is the telltale fingerprint of hydrogen gas falling onto a planet. In other words, it's a smoking gun for active accretion, the process of a planet literally drinking in material from its surroundings to grow larger. For planetary science, this is groundbreaking. It confirms long-standing theories. The gaps we see in disks are indeed shaped by young planets. And it shows us that planets don't just form quietly. They sculpt their environments dramatically, pulling in gas, pushing out dust, and reshaping their star system from the inside out. Even more importantly, this discovery closes a decades-long gap between theory and observation. For the first time, we can look at a protoplanetary disk and say, with confidence, there's a planet right there, and it's still being born. This has huge implications. It validates models of how giant planets migrate through disks while still accreting mass. It explains why planetary systems look so different, some ending up with the compact super-Earths, others with migrating hot Jupiters. And it gives us a living laboratory to study processes that shaped our own solar system 4.5 billion years ago. This isn't the first time we've glimpsed a baby planet, but it is the most direct and convincing. Take the famous case of PDS 70, a young star system about 370 light-years away. There, astronomers detected two protoplanets, PDS-70b and PDS-70c, inside a wide disk gap. Like Wispit 2b, these planets showed H-alpha signatures, strong evidence of active accretion. ALMA, the powerful radio telescope array, even spotted hints of circumplanetary disks, smaller disks of material that may one day form moons. But while PDS-70 gave us the first taste, this new detection goes further. With sharper adaptive optics and multi-night confirmations, astronomers have built a stronger case, eliminating doubts that the signals might just be quirks of the disk itself. Earlier candidates, spotted in systems like LKC, A15 and HD 100546, were exciting but controversial. Were those really planets or just blobs of hot gas or disk clumps? Without clear accretion signals, the evidence was never decisive. Now, with WISPIT 2b, the doubts vanish. We're watching a planet actively pulling in hydrogen gas from its star's disk, while sitting inside the very gap it helped carve. It's the missing puzzle piece that ties decades of theory to direct observation. And it's not just about one planet. It's about rewriting how we model the birth of entire planetary systems. So, why does this matter for you, me, and our place in the universe? Because what astronomers just witnessed is exactly what happened in our own solar system billions of years ago. Jupiter, Saturn, Neptune, they all carved gaps, migrated, and sculpted the architecture of our planetary neighborhood. Earth's story is part of this cosmic narrative. By watching a young planet grow in another star system, we're essentially looking back in time at how our own world was born. This discovery doesn't just confirm a theory, it lets us witness creation in action. It proves that planets are not passive passengers in their systems. They are architects, reshaping disks, guiding dust, and laying the foundations for future moons, atmospheres, and maybe, just maybe, life. And here's the exciting part. This is only the beginning. With instruments like ALMA, the Magellan Telescope, and the James Webb Space Telescope, astronomers are poised to catch even more of these cosmic births in action. Each one will refine our models and bring us closer to answering the deepest question of all. How common are planets like ours in the universe? So, what do you think? Will discoveries like this bring us closer to finding Earth-like planets being born around distant stars? And if we could witness our solar system's birth, what secrets do you think it would reveal? Let me know your thoughts in the comments below. And if you enjoyed this journey into the cosmic nursery, don't forget to like, subscribe, and hit the bell so you don't miss future explorations. Because here at Astroracle, the universe always has another secret waiting to be uncovered.